Welcome back, friends. The last lecture, we have discussed about CLR parser up to construction of the CLR parsing table. So in this lecture, we will discuss about how to parse the input string by using the CLR parsing table. So you see here, so we are performing the same problem what we took for SLR parser, and we have constructed the CLR parsing table here for this production rule, for this 3 production rule. So now the input string we are taking is terminal C, terminal D, terminal C, terminal D, and dollar. So this is the input string that we have to parse by using the CLR parsing table. So for parsing an input string, we need 3 components. One is stack, another one is input buffer, another one is action. So the initial element present in the stack will be dollar, and our initial state 0. So, and the input buffer will be having the terminals, collections of terminals. At the end, we will be having the dollar. And on the right hand side, we will be having action. So then next thing is it is shift. We will be performing what type of action based on the transition of the states and the input. Okay. So first state is 0. Initial state is 0. So that is mentioned, that is compared with the input 0, 0 and C. For 0 and C transition, we are having S3. The meaning is shift S3. So we have to perform the shift action, and the component present here is S3. The symbol present here is S3. So what we have to do is we have to shift one element from the input buffer to the stack. So dollar and 0 as it is, and this C will be transferred to the stack. Now the top element of the stack will be C, not C. After that, what we have to mention that the for performing the shift operation, the number mentioned is 3. Okay, so that 3 will be mentioned here. Okay, now compare with 3 and D. 3 and D. So D is here, 3 and D, that is S4. The meaning is shift S4. So what we have to do now, the D will be pushed onto the stack. Now the D is on the top of the stack. After that, the next top element of the stack will be the number what is present for the shift operation, that is 4. So 4 will be transferred to the top element of the stack. Now again compare 4 and C. So 4 and C is R3. So the meaning is we have to reduce, perform, if it is R means we have to perform the reduce operation. So it is mentioned with R3. So the meaning is third production rule. With the help of the third production rule, we have to perform the reduce operation. What is the third production rule? C tends to D. Non-terminal C tends to D. So this D will be reduced by non-terminal C. Okay. So dollar 0, this C, then 3, and this terminal D will be reduced with the non-terminal C. Now perform the transition for this 3 and non-terminal C. 3 and non-terminal C. 3 and non-terminal C is 8. That's why 8 is mentioned here. Now compare as it is the 8 and terminal C. So 8 and terminal C is R2. So reduce R2. The second production rule is non-terminal C tends to terminal C and non-terminal C. So we are going to reduce this terminal C and non-terminal C with the non-terminal C. So dollar 0. So these two things will be reduced with non-terminal C. Then 0 and C. 0 and non-terminal C. The transition has to be performed within 0 and non-terminal C. 0 and non-terminal C is 2. So now again perform the transition for 2 and C. 2 and C means you see here 2 and C is shift S6. Shift S6. We have to perform the operation, shift operation. So this C will be shifted to the top element of the stack. So here it is pushed, and the number is 6. 6 will be mentioned here. Then 6 and D. Compare 6 and D. 6 and D is S7. Again, we have to perform the shift S7, shift S7. So shift operation, D will be shifted to the top element of the stack. Then the number is 7 will be mentioned here. Now 7 and dollar. 7 and dollar is R3. So reduce R3. 7 and dollar is reduce R3. R3, the production rule is C tends to D. So the D will be reduced with, this D will be reduced with non-terminal C, and you have to mention, you have to perform the transition for 6 and non-terminal C. What is 6 and non-terminal C? That is 9. So that 9 will be mentioned here. Now 9 and dollar. compare 9 and dollar. So it is reduce R2. So reduce R2 means second production rule. What is second production rule? C tends to C and non-terminal C tends to terminal C and non-terminal C. So this terminal C and this non-terminal C is reduced by a non-terminal C. So before element will be present as it is $0 C2. This terminal C and this non-terminal C along with the 6 9 will be reduced with the non-terminal C. Then this 2 and C. 2 and non-terminal C is 5. 5 is mentioned here. Now compare 5 and dollar. 5 has the transition with the dollar with operation. What action it has to perform? Reduce R1. So reduce R1 means the first production rule. First production rule S tends to non-terminal C, non-terminal C. So both these non-terminal C's will be reduced with the non-terminal S starting symbol. So $0. Then this C will be reduced with S and 0, and now perform the transition for 0 and S. 0 and S is 1. So now compare with 1 and dollar, that is accept. Okay, you see here 1 and dollar is accept. So this is how we can perform the parsing of the input string by using the CLR parsing table. I hope you have understood the concept. Thank you.